Alright, in 6.2, the very first thing we're going to do is we're going to simplify radicals. And different than yesterday. Yesterday, what we had to do, it came out that it was perfect every single time. What we're going to do today is it's not going to be perfect every single time. And it may even start off with something like this, where you may have to do like square root of 50. That if you did square root of 50, it's not a perfect square root. And we've done these in the past. Let's just go back and remind you that if you were doing square root of 50, you got to break it down, right? 25 times 2. And again, you could have done 5 times 10. Take the 25 and break it down as 5 times 5. So if we had 25, it's 5 times 5 times 2. And as long as this one is square root, we're looking for everything in groups of 2. There's 2 5s, so we can move that 5 to the outside. The 2 doesn't have an exit buddy. There's only one of him, so he stays on the inside. So for that one, it'd be 5 square root of 2. So what they're going to do is, and again, we've done that in the past, so we've already kind of practiced through that one a little bit. We're going to do a little bit more with that today. Here's the big thing they're looking at in section 2, though. Is you're going to be doing something like this, where you're going to be simplifying the 4th root of x to the 9. I'm not going to show you the way the book does it, because they do it a little bit different way it works. They kind of do it, and I'll kind of see if I can tell you what they do, is they tell you that, okay, if you were setting this thing up, 4 won't go into 9 evenly, correct? Everything we did yesterday, if this would have been 8, we would have done 8 divided by 4, that would have been 2. This one doesn't go evenly. So the book does a little bit different way of showing you this one. Here's what I'm going to say we're going to do. We're going to take it back to 4th grade math. Go ahead and divide 4 into 9. Make it simple, right? How many times does 4 go into 9? 2 times. 2 times 4 is 8. 9 minus 8 is 1. Everybody okay with that? 4th grade math, right? Here's what we're going to do with 4th grade math. Every how many times this goes into this part right here, this is the number that's going to go on the outside. So basically we're saying 2 of the x's get out. There's going to be 1 x that's going to be left over on the inside. So this is going to be your outside exponent. This is going to be your inside exponent. And the book comes up with the same answer. They just go through it a little bit different way. So if you do the show me an example in the homework, it's going to give you an option. It's going to show you how to do it. It's just going to be a little bit different. To me, this one flows a little bit easier. So for this one, your final answer is going to be x squared, because we need 2 x's on the outside. We need 1 x on the inside. Now, the only thing you have to remember is, because it was a 4th root, you do have to put a 4 right here. And usually if I'm going to make a mistake doing these one homework problems, I tend to forget that index that's here. That's just, I just forget sometimes. So that's your answer. That's all you're looking for. Because again, your remainder, well, that's what you have to have left over. Since we started with 9 x's on the inside, you're going to be left with 1 x on the inside once you've paired them up. All right, example 2. Same kind of problem. Just change it up a little bit here. All right, let's go with the 5th root of y to the 17th. Okay, and again, the textbook, the online homework, they're going to have you work through and do grouping and pair stuff up and do things. Let's just keep it simple. Let's just divide 5 into 17. 5 will go into 17 3 times. 3 times 5 is 15. Gives you 2 left over. So when we rewrite it, we need the exponent of 3 on the outside. We need 2 that's left over on the inside. So final answer would be y to the 3rd on the outside. On the inside, we're going to need y squared. And again, it was 5th root, or the index of 5, so make sure you go back and put a 5 in your index there. Oh, and when you're going through the homework, because this is the first time we've done those on online homework. To get that 5 there, because it sometimes takes a little bit of practice, you're going to need the button that looks something like this. That on the online part of it, you're going to have a square root, and they're going to have a little box right here. Once you click on this box, it should automatically put you here, and you're going to have to go back and put your index of 5 or 4, or whatever it happens to be there. If it's just square root, you don't have to put that one there. You can just do that one. So if we had done the first, if we were doing square root of 50 back up here, that one, you wouldn't have needed the button that had that box in it. You could have just done the part that had the square root. But anything, if it's third root, fourth root, fifth root, you've got to find the button that looks like that, click on it, and put your index in, and then you can go back and put your answer around it. So that's the only thing you got to look for on that one, is just get used to that button that's there. All right, example 3. Let's go 6 root of y to 23. Oops, sorry. All right, so just divide it. We're going to take 6, divide it into 23. 6 going to 23 3 times. And again, if you're not sure, sometimes you get through your multiples and you're not real sure, just take 23 and divide it by 6. All you need is the whole number of 3, and then you can do 3 times 6 to get to 18. Then you can subtract those 2 and figure out what you got left over. So we need 3 on the outside, 5 on the inside, so we're going to have y to the third. We need the 6th root of y to the fifth. Okay, so if you have the variables that don't work out evenly when you do the fraction part of it, because we had the 23 over 6 here. Well, if it doesn't work out, just do regular 4th grade math division. Take the 6, divide it, see what you got left over there. All right, now, if they happen to blow your mind and give you 2 variables, oh no. What are we going to do with 2 variables? Well, we're going to do them one at a time, right? So if you have the 4th root of T39 and B17, just do it one piece at a time. We're going to do, for the T part, we're going to do 39 divided by 4. For the B, we're going to do 17 divided by 4. Okay, and when you do these, I would say do the division right underneath it so that you know what variable goes where. So take the 4, divide it into 39 right underneath the T. For the B, we're going to take 4, divided by 17. Okay, if that was 40, it would go 10 times. So since it's just a little bit less, it's going to have to go 9 times. 9 times 4 is 36. Subtract those, and we've got 3 left over. For the B's, 4 going to 17 4 times. Got 1 left over. And the good thing about doing that is if you do them right underneath the variables, you've got both of the outside numbers here. So on the outside, we're going to have 9 T's, and we're going to have 4 B's. And then on the inside, we're going to have 3 T's and 1 B. So for this one, again, we're going to go T9 on the outside, B4. So we've got T9, B4, and then on the inside here, we're going to have 3 T's, and you're going to have 1 B. And since it's B the first, you don't have to put the 1, you can just put it as B there. Okay, so when you're doing these, again, let's don't make it complicated. Just take it one little piece at a time, and just realize that if you're going to do the T part of it, there you go. So you're going to need 9 T's on the outside, and then we do the B's. We're going to need 4 B's on the outside, and we're going to need 1 B on the inside. So just take it one piece at a time, and then just go back and fill in the gaps where you need to. Okay, so when you're simplifying, that's pretty much about it. Just take the numbers, do 4th grade math, and then we'll go. So we'll keep it as easy as we can here. So once we've gone through doing the simplifying, they're going to ask you next to go ahead and do some multiplying. And with multiplying radicals, we're going to do basically just two things here. I mean, technically it's three, but two main things we're going to do for this part of it. Alright, and the biggest thing to remember is when we're going back yesterday, this is your index and this is your radicand. So the index is the root, or whatever you have that's here. The radicand, that's the numbers you have on the inside of the radical there. Okay, now the one thing you don't have to worry about in this section, but we'll just kind of mention it, is that the indexes have to be the same. But the good thing is when we go through these problems in the homework, there's no trick questions. That they give it to you so that the indexes are all the same. They're all second roots, they're all third roots, they're all fourth roots. So that part of it, you're not going to be trick question here. Okay, once the indexes are the same, and they'll all be this way, you're going to do really two main things. First thing is you're going to multiply the radicands. Again, the radicands are the numbers that's on the inside of the radical. Second thing you're going to do is, if there happen to be some coefficients in front of the radicand, multiply those. So we're going to multiply the coefficients. Again, the coefficients are just the numbers in front of the radicand. And this one, it's maybe 50-50. I don't even know if it's that much. That most of the time, you're definitely going to have to do step one. Step two, that may happen 25% of the time. It's not going to happen very much. Mostly right now, they're making you worry about the radicand. And then the last thing you have to do is you have to simplify the radicand if it's possible. And for about 99% of them, you're going to have to simplify the radicand. There may sneak in one problem through the homework when you're going through these where you're not going to simplify the radicand, but almost all the problems you're going to do, you're going to have to simplify the radicand. All right, let's do about 4 of these, make sure we're good, and then that may be about all the time that we have before we run out of time today. Okay, so for the first example, we're going to go with third root of 18 and third root of 3. And if you did a quick check, you're like, oh, I can just do this on the calculator. If you do that, if you do a third root of 18 times the third root of 3, it's not going to get the answer that you need because it's going to be a decimal number. So if you get a decimal number, you cannot give me a decimal number on the test. It's going to say put it in the simplest radical form. So that's not going to help you out if you go through this here. So for this one, first thing is we're going to multiply the radicand. So we're going to put it together, make it the third root of 18 times 3. Okay. There's no coefficients. You don't have any numbers in front of the radicands, so we're not going to worry about step 2. Now we're going to simplify it. And here's the thing we're going to do for these. When we do 18 times 3, that would be 54, but you don't have to write the 54 because we're going to break these down just like we did with these. We've got to break it down so it's in simplest form as far as prime numbers go. So we're just going to leave this as 18 times 3 and just start breaking down the 18 here. So 18 would be 3 times 6. 6 would be 2 times 3. So if we go back and get all the prime numbers, we've got a 3, 2, 3, and a 3. And because we're doing the third root on all these, looking for everything in groups of 3's, well, there's 3 3's. So that 3 gets out. There's only 1 2, so it's going to stay on the inside. And then that would be the answer that we're looking for this one. Yes. Okay, for the next one, we'll keep some small numbers, but we're going to throw in a couple of variables at the same time. So let's go with the square root of 8x to the 5th times the square root of 3x. Okay. And again, indexes are the same, so that's really not going to be an issue, so we're okay there. Step 1 is we're going to take and multiply this together. And when you multiply these, let's go ahead and do 8 times 3 and actually put that together. And then put your variables together. X to the 5th and x. And it's probably a good idea to go ahead and put an x1 in, because that is x to the 1st if it's there by itself. Sometimes if you don't do that when you put it together here, sometimes that 1, sometimes it's easy to kind of forget about it. So for the 8, let's break it down. 2 times 4 is 2 times 2. So for that one, we've got a 2, 2, 2, and a 3. And for the x's, just add them together. 5 plus 1 makes it x to the 6. Alright, and we're doing square roots. We need 2 of a kind, so there's 2 2's when we take the 2 out. There's only 1 2 left over, 1 3 left over, so those will stay on the inside. As far as the variable goes, it's 6 divided by 2, right? But what is 6 divided by 2? Just 3. And no leftovers, correct? So, and if there's no leftovers, then that means there's no x's left on the inside. So final answer is we're going to do 2 x to the 3rd. And on the inside, go ahead and do 2 times 3 and make that out to be 6. Okay, so when you're doing these, just do the numbered part, break those down as much as you can, and then look at the variable part, and then just divide the index into the exponent and figure out what we have there. Alright, for example, let's go back to third root. Let's go with third root of 4x to the 5th y times third root of 6x squared y to the 4th. Okay, so under 2 separate square roots, let's go back and put it so it's under 1 big square root. The first thing is we got 4 times 6. We've got x to the 5th and x to the 2nd. We've got y to the, and again, I'd go ahead and put y to the 1st from this one, and y to the 4th. Okay, so 4 and 6, go ahead and start breaking down. 4 is 2 times 2. 6 is 2 times 3. And that worked out kind of nice because everything's already in order for this one. We've got 2 times 2 times 2 times 3. For the x's, we have 7. And for the y's, we have 5. Okay, from the numbers, we need 3 of a kind. So there's 3 2's. So that 2 gets out. There's only 1 3 left over, so it will stay on the inside. For x to the 7th, we're going to take 7 and divide it by 3. For the y, we're going to take 5 and divide it by 3. And again, when you do these, just keep it simple. Let's just do, again, back to 4th grade math here. Let's take 3 and divide it into 7. 3 going to 7 2 times. 1 left over. So that's what goes on the outside. That goes on the inside. And for the y's, same thing. We're going to take 3 and divide it into 5. Goes 1 time with 2 left over. There we go. So again, everything here goes on the outside exponent. Everything here is what's left over on the inside. Okay, so number-wise, we had a 2 on the outside. And here's where we got to leave a little bit of space. We had a 2 on the outside. We had a 3 on the inside. For the x's, we need 2 on the outside, 1 on the inside. And for the y's, we need 1 on the outside and 2 on the inside. And that would be the final answer. Alright, let's do one more with some big numbers. And that's pretty much going to be our stopping point there. So we'll get through the multiplication, do one more example of that one. Tomorrow we'll pick it back up with the division. And then we'll just start running from that part of it. Alright, last multiplication problem. Let's go with the square root of 45 x to the 5th y to the 3rd times square root of 35 x y to the 4th. Because all the numbers we had so far were kind of small. We did 8s and 3s and 6s and 4s. Let's throw some bigger numbers out there. Let's go with 45 and 35. Alright, so just separate everything by what they are. You have 45 times 35. We've got x to the 5th here, and an x here. And again, I would go back just so we don't lose anything. Just put that as x to the 1st, because if it's x there by itself, it's still x to the 1st. Y to the 3rd from the first one, and y to the 4th from the next one. Okay, and variable-wise, those should be easy. You've got 1 plus 5, make that x to the 6th. 3 plus 4 makes that y to the 7th. It's the 45 and the 35. That's the part we've got to take these and break them down. 45. You can do 5 times 9. You can do 3 5 times 15. Doesn't matter. Just start breaking it down. 15 would be 3 times 5. Okay, so with 45, we've got 3, 3, and 5. 35. It's 5 times 7, and that's as far as it goes, right? Because 5 and 7 are both prime. So that would be it. Okay, so for that part, we've got 3, 3, 5, 5, 7. And as far as these go, once we've got these together, we can basically just do the division here, because this is going to be x to the 6th. And we're going to divide it by 2. For the y, same thing, it's going to be 7 divided by 2. And we just work it out. Pair of 3s, so that 3 gets out. Pair of 5s, that 5 gets out. The 7 did not get out, it stays on the inside, so it's still there. And for the y's, 2 goes into 6 3 times with no leftovers. 2 will go into 7 3 times with 1 leftover. So everything up here on the top goes outside. Everything left over is what's left over on the inside. Okay, so outside we've got 3 times 5 for 15. You've also got 3 x's on the outside. We also have 3 y's on the outside. On the inside we've got the 7, no x's, and 1 y.